Hey guys, welcome to Pre-Calc, lesson 9.7, graphing trig functions. Before we get to graphing, I want to do a quick warm-up on evaluating trig functions. 1a, cosine 3 pi over 4. So the process here, you would take a look at pi over 4 and immediately recognize we're talking about a 45-degree reference angle, and you need to have memorized that cosine of 45 is 1 over square root 2. So I know my final answer is either 1 over square root 2 or negative 1 over square root 2. Last thing to determine, is this positive or negative? To do that, we have to figure out what quadrant we're in, and 3 over 4 is slightly less than 1. So we're slightly less than 1 pi, which puts us in the second quadrant. Since sine is positive there and all others are negative, cosine will be negative. B, sine 300 degrees. We don't work with degrees a whole lot. And you can see that 300 degrees is actually a little bit more challenging than if we were working in radians. Here's why. The reference angle isn't as obvious. So where is 300 degrees? Fourth quadrant, that part's pretty easy, right? A, S, T, C. So right now, since that's cosine's quadrant, I'm evaluating sine, I know my answer is going to be negative. Here's the issue that we have. Remember, the angle's always drawn to the x-axis. So my reference angle is 60 degrees. That's the difference between 300 and 360. So sine of 60 degrees we need to have memorized is square root 3 over 2. The next two, we're going to use our calculator. The only minor difficulty here is you have to make sure you're in the appropriate mode. If I want to evaluate tangent pi over 5, I could put that right into the calculator. Just make sure you're in radian mode. Okay, so if you put that in the calculator in radian mode, let's see, I got 0.7265 rounded to the nearest 10,000th. And secant 40 degrees, 15 minutes. Obviously, we need to be in degree mode. And there is a way to put in a degree symbol and a minute symbol. Remind me, I'll have to show you in class. I can't bring my calculator up here on this screen, unfortunately. But you go to, there's a button for degree. And you go to that and you can enter the degree symbol. You can also enter the minute symbol. The other difficulty here is there is no secant function on your calculator. So remember, secant is the reciprocal of cosine. So what you would enter in the calculator is 1 over cosine 40 degrees, 15 minutes. Okay, and if you do that, I got 1.3102 to the nearest 10,000th. Okay, let's talk about graphing. This is something we did last year in Algebra 2. You might not remember much of it, but we're going to start real slow today and build every one of these, so it should come back to you relatively quickly. If I give you this general form equation, y equals a sine bx, A stands for amplitude. And that is the distance from the center to the crest, or the center to the trough. So from the middle to the high point or middle to the low point. And remember, amplitude is always positive. You might see a negative in front of your trig function. That doesn't mean the amplitude is negative. That just means we're doing a reflection in the x-axis. So amplitude is a distance. It's always positive. B we call the frequency, and this gets a little bit tricky when we're talking about time versus traditional 0 to 2 pi. So for the beginning part of graphing, think of frequency as waves between 0 and 2 pi. Later on, when we talk about harmonic motion, we'll talk about frequency per unit of time, and it's going to be a little bit different. Period is the length of one cycle or wave. And there's a way you can calculate it. It's always 2 pi over the b term in that equation. So 2 pi over whatever's in front of the x. Okay, so let's figure out how to graph these. Y equals sine x. Well, the first thing we're going to do before we get to the graph is let's talk about the unit circle. Oops, sorry. So here's my unit circle. Coordinates are going to be very important. So that coordinate there is 1, 0. This coordinate here is 0, 1. That coordinate there is -1, 0. And this coordinate is 0, -1. We're going to talk about radians. This is 0 radians. This is pi over 2. Here is pi. This is 3 pi over 2, and then all the way back around to 2 pi. The next thing we want to remember is that every point on the unit circle can be expressed as cosine theta, sine theta. And we're going to use that to create our graph for sine x. So here's my y-axis. Here's my x-axis. One thing I want you to notice, we're going to do sine first. Sine is the y value. So I'm looking here at 0. Sine is 0. Then what happens to your y value as you move around the unit circle? Well, it increases from 0 to 1. And then what happens to the y value? It decreases from 1 back to 0. Then the y value keeps decreasing until it gets to -1. Then it increases back to 0. So if you just think about the y value, it starts at 0, goes to 1, back to 0, down to -1, back to 0. But we want to express that on a coordinate plane. So here's how we're going to label this. I want to label the 4 quadrantal angles. So I've got pi over 2. I've got pi, 3 pi over 2, and 2 pi. So that will represent these angles. 0, pi over 2, pi, 3 pi over 2 to 2 pi. Obviously, that's going to be 0. The greatest y gets is 1. The lowest it gets is -1. All right, so I'm going to make this just a little bit bigger so it's easier to graph. Go up to 1 and go down to -1. I don't need to go any higher or any lower. And then what I want to do is transfer these points. What would this represent on a coordinate plane? How about this one? How about this one? How about that one? And then back to here. Well, it's going to look like this. At 0 pi, sine is 0. At pi over 2, sine is 1. So right here, I've got that point. Well, then what happens at pi? It goes back to 0. At 3 pi over 2, it goes to -1. And at 2 pi, it goes back to 0. So I have a graph that looks like this. And we're going to do a little bit better job of graphing these this year because when we get to calculus, we're going to talk about something that's called concavity, which is the way the curve is. So this is what we would call concave down. It's like an upside down bowl. And then this part is concave up, like a U. And here at this point, it changes from concave down to concave up. So when we graph these, we want to make sure we've got the correct concavity. So that's what sine looks like. And obviously this would continue, right? Because I can keep going around the unit circle in any direction. So this is just one cycle, but this would keep going and that pattern would continue forever in this direction and also in the positive direction. Now on this graph, let's label some parts. This is the amplitude right here. Okay, so that distance, in this case, the amplitude is 1. Now notice there's several areas you could find amplitude. This is also the amplitude. The period is the length of one cycle. So this right here represents the period. And that's the basic shape of our sine graph. One thing you'll hear me say quite often is, well, okay, what's the basic shape of sine? And you're going to think, oh, it's hill, valley. This is assuming no transformations, hill, valley. Remember that as we move on to cosine. Let's take a look at cosine. I'll set my axes up the same. So here's my y-axis, x-axis, and let's label this 4 quadrants. So I've got pi over 2, pi, 3 pi over 2, 2 pi. And as you can imagine, the maximum cosine gets is 1, and the minimum it's -1. So before we get to the actual graph, let's go back and look at that unit circle real quick and talk about cosine and what cosine does. Cosine is the x value. Here's 0 radians. So at 0 radians, cosine is 1 because it's the x value, so we're starting out here. So think about what the x value does. Starts at 1, decreases to 0, keeps decreasing all the way to -1. Then it increases to 0, back to 1. So my cosine, starting at 0, goes 1, 0, -1, back to 0, back to 1. So it actually starts at the maximum value. It starts at 1. So let's put those points on this. So at 0 radians, cosine is 1, starts at the maximum. Then at pi over 2 decreases to 0. At pi decreases to its minimum value of -1, goes back to 0, and goes back to 1. So now when we sketch this, remember we talked about with the concave up and concave down. Anything above the x-axis has got to be concave down, so it's curved like this. Now anything below the x-axis, is concave up, like a U. And then changes concavity again and is concave down to 2 pi. So like sine, my amplitude is just 1, right? Here's the amplitude from the center to the maximum. You could also view amplitude as center to the minimum. And remember, it's a distance. So either way, we're talking about 1. And the period is 2 pi. 1 cycle. Maximum to maximum is 1 cycle. And this pattern would continue, obviously, in the negative and the positive direction. We are just looking at 1 cycle. Okay, let's move on to our last trig function that we'll be graphing, and that's tangent. And tangent is a little bit more confusing, because if you remember how tangent works, we have 0, undefined, 0, undefined, 0, and it just keeps going back and forth. So we need to be a little bit, here's my theta, a little bit more careful the way we do this. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And there's that trick I told you guys with the slope is 0, tangent 0 if the slope is undefined, tangent's undefined. So at 0 radians, tangent is 0. At pi over 2, it's undefined. At pi, it's 0. 3 pi over 2, it's undefined, and so on and so forth. So it doesn't give us a whole lot of information. But I want you guys to remember this. In between here, 0 and 2 pi, I've got pi over 4, which is 45 degrees. And if you think of your 45, 45, 90 right triangle, tangent of 45 is 1. So let's remember that when we sketch this graph. Okay, so here's my y-axis, x-axis, and I'll label it the same way I labeled the one up above. Got pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so what do we know about tangent? At 0, tangent 0. Okay, so 0, it's 0. At pi over 2, it's undefined. What does that mean in a graph? If it's undefined, that basically gives us a vertical asymptote. At pi, it's 0. At 3 pi over 2, it's undefined, so there's another asymptote. And at 2 pi, it's 0. So that is not super helpful to us. How do we fill in the rest? Well, remember how an asymptote works. All right, so my graph will approach it. So it's going to look something like this or something like this. I'm not quite sure yet. Same thing in this region. If that's an asymptote, maybe I have something that kind of goes like that or like this. So how do we get those other points? Remember, pi over 4, which is halfway between 0 and 2 pi. So this is pi over 4. What is tangent of pi over 4? 1. So I will add a 1 here and a -1 here. And between 0 and my right asymptote, tangent's going to be 1. So that gives me one additional point and really kind of locks in what this graph has to look like. So now what I need to do, because remember, these are periodic, this pattern repeats over and over and over again, is think about what's going to happen between here. Well, look at this piece. This is actually the right asymptote of this section. I don't see what's going on over here, but you can probably guess. And then you just need to repeat that over here. And remember that between an asymptote and 0, it's got to be either a 1 or a -1. So in this section, obviously, it's going to be a -1 between the left asymptote and 0, and over here it's going to be a +1. So this is how you create that pattern for tangent. This is the best representation of one cycle right here. Between two asymptotes, I get this curve. And basically what happens is that curve just repeats over and over and over again. And when you only see half of it, you have to think about, okay, am I looking at the right half, which is what this is, or am I looking at the left half, which is what's going to be over here? So over here, we go to -1, and we just fill that in. So there's one cycle of, well, this is one cycle. This is actually two cycles of tangent, right? Because look, I can consider this one cycle, and then I have another one here. So since this is two complete cycles, the period of tangent is pi. And that's pretty important when we talk about how to come up with the axes and the asymptotes, is understanding the period of tangent is pi, but the period for sine and cosine are both 2 pi. Okay, let's take a look at graphing these trig functions with changing of the period, the amplitude, and also frequency. All right, find the amplitude, period, and graph two full waves. When I give you the equation of a trig function I'd like you to graph, we're going to go through this process. Write down the amplitude. Amplitude is always the coefficient in front of the trig function. So in this case, it's 2. Remember, it's always positive. That negative means something else. Amplitude is 2. The frequency, or the b term, in this case, is just 1. That's whatever's in front of the x here. So that's a 1. And super important, period is 2 pi over b. In this case, that's 2 pi over 1, or just 2 pi. The period tells us how long one wave is. Now, before I even think about labeling my axes, I'd like you to make a thumbnail sketch. And this is where we incorporate that negative. And basically what I like to do, I'll do this over on the side, is memorize 4 shapes. Here you go. Y equals sine x, looks like this, hill valley. Y equals negative sine x, looks like this, valley hill. It's a reflection in the x. Y equals cosine x, starts at the max, ends at the max. And then y equals negative cosine x, starts at the min, ends at the min. It's a reflection of cosine in the x-axis. So I have those visualized. So when I want to make my thumbnail sketch here, I see I have a negative cosine. All right, so I think of a negative cosine. That's going to be one cycle. How long is one cycle going to be? Whatever your period is. In this case, 2 pi. So that's going to be 2 pi. I'm going to change the directions here a little bit for the sake of time. I'm going to say 1 full cycle. Now, how do we set up our axes? Because they're not going to be set up for you. You have to understand that what we want to do is take the period and divide it by 4, because I need a point here, 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 and here. I'm divided up into 4 regions, like my 4 quadrants. Okay, let's put our y-axis all the way on the left. I just find that easier. X-axis somewhere around the middle. And you want to make sure you go out 4 blocks and space it evenly. So I usually try and maximize the area on the graph. So there's 1. I went out 4 blocks, go out 4 more blocks, 4 more blocks, 4 more. And basically we want to go to 2 pi. Divide that by 4. So if this is 2 pi, you want to work backwards, well then this has to be pi. And then this has to be half of that, so that's pi over 2. And then between pi and 2 pi is 3 pi over 2. And my amplitude is 2. I would prefer it if you didn't go 1, 2, and just make this tiny graph. So remember, you can go up as far as you want and label it a 1. So you can go do something like that, or not quite so far. So maybe I'll go up 3 blocks, call it 1, go up 3 more blocks, call it 2. You always have to label your axes. Make sure you're consistent. All right, so that's all I need for labeling. Next, what I want to do is transfer these points here. The low point, 0, max, 0, and then the min. And since I labeled my axes according to this and that, it's easy to do. Okay, so I'm going to start at the low point, which is -2. Then I go to 0, which is my period divided by 4. Then I go to 2, back to 0, and back to your low point. This would be concave up. This would all be concave down. And then this would be concave up, curved that way. So there you go. There's one cycle of that function. Let's do the same thing here. Y equals sine 2x. I just want to sketch one cycle. First thing we do, amplitude. All right, so my amplitude is 1. My B, or my frequency, is 2, which tells me there are 2 waves between 0 and 2 pi, which obviously means I need to change the period. Period is 2 pi over B, or frequency. In this case, it's just pi. So now when I make my quick thumbnail sketch, I have positive sine, so that's hill valley, and the length of one cycle is the period. Okay, so that is pi. That's going to determine how I set up my axes. Okay, let's put the Y all the way over here on the left. X somewhere in the middle. And like I did up above, maybe I go out 4 blocks, put a mark, go out 4 blocks, put a mark, 4 blocks, put a mark, 4 blocks, put a mark. But now, that is going to be pi. I'm dividing this up a little bit differently because we changed the B, we changed the frequency. So if this is pi, this has got to be half of that. So that's pi over 2. What's half of pi over 2? Pi over 4. So basically, if this is 1 pi, I'm going by fourths. 1/4, 2/4, 3/4, 4/4. So 2/4 simplified is pi over 2. This has got to be 3 pi over 4, and 4 pi over 4 is just 1 pi. Okay, so this is 3 pi over 4. Amplitude is 1, so you can set the scale whatever you want. I'm just going to go up, let's say, 2, 4, 5 blocks, call it 1. You can go up whatever you want. Just label it 1. Just make sure you go down the same number. 1, 2, 3, 4, 5. So that's -1. So now what I need to do, because I've got this organized already, period divided by 4, is transfer these points to the grid. So sine's going to start at the origin and then go up to 1, down to 0, to -1, back to 0. Okay, so it starts here, goes to the maximum at pi over 4, back to 0, to the minimum at 3 pi over 4, back to 0. Concave down here, concave up there. Okay, and there's a very good sketch of that trig function. Example 3, y equals 3 cosine 1/2 x. So now we're going to be changing amplitude and the frequency. Go through the same progression here. Amplitude equals 3. The b term, or frequency, equals 1/2. The period equals 2 pi over the b term over 1/2. We're going to see this quite often. Anytime your b term is less than 1, you're going to deal with this. Remember what we do: copy, change, flip, multiplied by 2, multiplied by 2. Oh, that's just going to be 4 pi. Okay? So, thumbnail sketch. Cosine. I have to memorize cosine. Starts at the maximum, ends at the maximum. This right here, one cycle, is going to be the period, 4 pi. This actually is a little bit easier. I don't have to deal with the fractions like I did before. So let's sketch our y-axis here. X-axis here. And let's go out 4 blocks. So 1, 2, 3, 4. That will be 4 pi. This has to match that. Well, that's pretty easy, right? If that's 4 pi, I'm going by 1 pi each interval, so that's pi, 2 pi, 3 pi. My amplitude is 3, so let's see if I can maximize this. I'll go up 2 blocks, call it 1, 2 more blocks, call it 2, 2 more blocks, there's 3. So in this direction, -1, -2, -3. All that's left to do is transfer these points, the maximum, the 0, the minimum. Back to 0, back to the maximum. That will give me one cycle. Okay, amplitude is 3, so that's my maximum. Then to 0, then to my minimum at 2 pi, back to 0 at 3 pi, and back to the maximum at 4 pi. Concave down, concave up all the way between pi and 3 pi, and then concave down for the rest. All right, next, y equals tangent 2x. Tangent is very tricky. We've got the asymptotes to work with. It changes the period. So what I like to do with tangent, first of all, is determine what the b term is, or the frequency. And that's 2. Tangent doesn't have an amplitude, right? Because it goes up to positive infinity, goes down to negative infinity, so the amplitude is infinity always for all tangent graphs. So I only have to deal with the b term. Now, remember for tangent, period is not 2 pi over b, it's pi over b, or in this case, pi over 2, because the tangent period is pi. So the period for this particular function, if it says tangent 2x, is pi over 2. Well, it's still not really clear to me what I need to do, so I also want to consider this equation that I only deal with for tangent, and that is, where are the vertical asymptotes? And there's a couple different ways you can approach tangent, but I like to think of it this way. My first 2 vertical asymptotes are plus or minus the period divided by 2. So in this case, it's going to be plus or minus pi over 2 divided by 2. Copy, change, flip, that's plus or minus pi over 4. Well, how does that work? Let's set up my axes this way. And you'll notice I do this a little bit differently than I do sine or cosine. You don't have to do it this way. I just find it easier to sketch one cycle of tangent. All right. Well, to set up my axes, I want to use this because that's where my asymptotes are going to be. So I'll go out, let's say, 4 blocks, call that pi over 4. Then I have to go out 4 more blocks, and if that's pi over 4, this would be pi over 2, right? 2 pi over 4, and just simplify it. And then to keep things symmetrical, I like going the negative direction, so that's negative pi over 4, and this is negative pi over 2. I just find this easier for tangent. You don't have to do it this way, like I said. I know my vertical asymptotes are at plus and minus pi over 4. So at those 2 values, I'll sketch in the asymptotes. To me, that makes it very easy to sketch one cycle of tangent because I know the basic shape of tangent looks something like this. And then that pattern is going to keep repeating over and over and over again. There's only one more thing that I would like you to do to be a little bit more specific, and that is mark where 1 and -1 are. Because we said between the 0 here and the positive asymptote, or the asymptote on the right, tangent's going to be 1. And then between the 0 and the asymptote on the left, tangent's going to be -1. So it's going to go through those 3 points and then curve towards the asymptotes. All right, so let's put those in. Here it's 0 in between. There it's 1. Here it's -1. Okay. But I want to sketch more than just one cycle for tangent. Let's go all the way out here. Let's use this window. Now, if we think about it, if this is one asymptote here and that's one asymptote there, I'm not going to see another asymptote in the window. It would be out here and out here. So in this space, in this part of the window, I'm going to see the left piece of this cycle. So it's going to look like this. In this window, That's the right asymptote, so I'm going to see this piece of the cycle. So if I want to get those other pieces, this would be a -1, that would be 0, look like so. And that negative pi over 2 would be 0. Between there and the right asymptote, it would be 1. And I sketch that in. So you can see that pattern would continue and have an asymptote here, like so. Okay? That one is a little bit more challenging. Fortunately for you guys, we don't do a lot with tangent. You will have to sketch either tangent x, tangent 1/2 x, or tangent 2x, but we don't do much beyond that. Now let's take a look at another transformation. Y equals a sine bx plus d. So we're adding a vertical shift. A is still our amplitude. B is still the frequency, which is the number of cycles between 0 and 2 pi. And D is a vertical shift, up or down. All right, first example, very straightforward. We've already done y equals sine x. This is just going to be y equals sine x plus 1. Remember the first three things we do. Amplitude, in this case, is 1. B, or frequency, also 1. Immediately following that, we do our period, which is 2 pi over 1, which is just 2 pi. And we should also note here, we are shifting this up 1. Before I label my axes, what I'd like to do is that quick little thumbnail. Y equals sine x is hill valley. And I make sure I know what one period is. That's 2 pi. So one cycle is 2 pi units long. All right, set up our axes. Y-axis over here, I'm just doing one cycle. X-axis, I go out 4 blocks, and that's going to be 2 pi. Remember, you always take your period and divide it into 4 blocks. So let's see, 1, 2, 3, 4. That's 2 pi. So obviously that's pi, pi over 2, and 3 pi over 2. Now my amplitude is 1, but don't forget we're also shifting this up 1. So I want to spread this out a little bit. I'll go up 4 blocks, make that a 1. Go up 4 more blocks, make that 2. And then just for the sake of thorough labeling, I'll make that a -1. Now before I sketch these key points in, what I need to do is determine where that new horizontal is. It's up 1. So what I'm going to do is put a dashed line here. It doesn't represent an asymptote. It's just going to help me with the graph. Since I'm shifting it up 1, that's my new midline. This now represents this. So normally I would start here at the origin, but I've shifted that up, so that'll be at that point. Then I go to the maximum. Since my amplitude is 1, I go from 1 to 2. Then back to your midline. Then to your low point, which is 1 below the midline. Back to your midline. Concave down, followed by concave up. And there's a quick graph of y equals sine x plus 1. Y equals 2 cosine pi x minus 1. So we've got a lot going on here. First, amplitude. 2, frequency, or your B term, in this case is pi. So there's pi cycles between 0 and 2 pi. Well, that doesn't make a lot of sense to me, but this will, when you do period, 2 pi over b, notice what happens. The pi's cancel out, and the period is 2. So now my period is not in terms of pi anymore. It's just in terms of integers. It's 2. That makes it actually a lot easier. And I notice here, I'm going to shift this down 1. Let's talk about our thumbnail sketch. This is a positive cosine, which starts at the maximum and does this. And one cycle, this right here, is going to be 2. Again, this is going to make it a lot easier because I don't label my x-axis in terms of pi's anymore. It's just going to be 2. All right, so let's sketch our axes in. Y there, x here. I'm just doing one cycle. Again, to do 2 cycles, it's pretty easy. You can go in the negative direction or just double this. Let's go out 4 blocks. 1, 2, 3, 4, and that's 2. So to label this, half of 2 is 1, half of 1 is 1/2, and then between 1 and 2 is 3/2. My amplitude is 2, and I'm shifting this down 1, so I'll try and maximize my area here. That's 1, that's 2. Keep your scale consistent, -1, -2. What I need to do next is determine where this midline is. That's called a midline. It's down 1, so it's going to be here. Sketch that in as a dotted line. It's not an asymptote, it's just a new midline. All right, so now we have to transfer these points in relation to my x scale and this midline. So this point right here is going to be the amplitude, so up 2 from my midline. Okay, so from my midline up 2, that would be right there. Then it goes to the midline. Then it goes down below, so I need to include a -3 there. I forgot to do that. So that would be 2 down from the midline at 1, back to the midline, and then 2 above the midline at 2. Concave down for this section, concave up from 1/2 to 3/2, and then concave down again to finish it up. So there's a graph. It's got an amplitude of 2, right? This is 2. Here's my amp. The period is also 2, and it's been shifted down 1. All right, last one for the day. Amplitude, period, horizontal, and vertical shifts. Well, we skipped that. We're not doing horizontal shifts today. We'll do that tomorrow. Graph 2 full cycles. Let's just do 1. Okay, here we go. Amplitude, 4. Frequency, or the B value, pi over 2, which means the period is 2 pi over pi over 2. Let's do our copy, change, flip. Multiply by 2 over pi. And pi's cancel. 2 times 2 gives me 4. So the period is 4. You probably picked up on this, but what's nice, when pi is in your frequency, your scale doesn't have pi. 1, 2, 3, 4. It makes it a lot easier to label that x-axis. And I also notice here, I am shifting this up 2. So let's do our thumbnail sketch. Sine, hill, valley. How long is one cycle going to be? Whatever the period is. In this case, it's 4. So one cycle is going to be 4. All right, let's set up our axes. Y-axis there, x-axis here. I'm only doing one cycle, so I'll go out 4 blocks. 1, 2, and make sure your scale is consistent. 3, 4, and that is 4. The 4th block matches your period always. And then just depending on what this is, you label those. Obviously, piece of cake in this case. 1, 2, 3. My amplitude is 4, and I have to go up 2. So I have to make sure my scale, let's see, 1, 2. All right, so I actually have to make this a little bit smaller. I don't think I have room to go by 2s. So if that's the case, if each block is going to represent 1, how do you just label every other? So there's 2, 4, 6, and then this would be -2. I don't think I need to go down there. Okay, so my midline has got to be up 2. It's going to go right there. So let's sketch that in as a dotted line. That is the new midline. And what I need to do now is transfer these points. Midline, maximum, midline, minimum, back to midline. Okay, I'm going to start right there. So that is going to be my middle value. And then I go to my maximum. Since my amplitude is 4, I have to go all the way up to 6. So right here, I go up to 6. Back to your midline here. Then I go to my minimum, which is down 4. So 2 goes down to -2, should be right there. Back to your midline. Concave down, followed by concave up. And let's do a quick check. Amplitude is 4, so this distance here is my amplitude, 2 to 6. Yep, that's 4. The period is 4, so this length of one cycle is 4. Yes, great. And I went up 2. My midline is up 2. All right, I know this has been a long day of notes. I apologize for that and appreciate you guys following along. Please reach out if you have any questions. Thanks for watching, and we'll see you in class soon.